This is review problem number 1 for assessment number 5. They want us to solve the triangle, and they give us angle B, which is 45 degrees, and they give us side A, which is 28, and side B, which is 27. So let's draw the triangle first. And I'm going to call this A, B, C, which means this is little c, this is little b, this is little a. I just like to label my triangle like that about every single time. 45 degrees for angle B, that's right here. And we'll have side A, which is 28, and side B, which is 27. Now, as you can see, we have a side-side angle. So we have SSA, side-side angle. In this situation, side-side angle, we know that sometimes we can get 2 solutions, sometimes we get 1 solution, sometimes we can even get no solution. How can we tell? Well, this is how we tell. We look at the side that is touching the angle. What's the side length that's touching the angle? That's side length A, and it's 28. If side length B, which is opposite of the angle, is smaller than 28, we've got 2 triangles. If it's larger than 28, we've got 1 triangle. And if it's so small that it's actually smaller than the right triangle that this would create, then we have a no solution problem. Well, in this case, it is smaller than 28. So we have 2 choices. It's either no solution or it's 2 solutions. Okay, how do we tell if it's no solution or 2 solutions? Well, what we're going to do is we're going to draw this triangle here. We're going to draw like a fake side for this 45-degree angle. We're going to find what's the side length. So basically, what's the minimum side length we can have for this side B? Well, we can find this using sine, and we can say sine of 45 equals opposite, which we're going to call this just x over 28. Multiply the 28 over, we get 28 sine 45 equals x, which is, plug in the calculator, 28 sine 45. 19.8. So the smallest possible side length for B is 19.8, which would give you the right triangle. If you get any smaller than 19.8, this side now comes off of side C and isn't touching it, and it's not a triangle. So in this problem, because 27 is bigger than 19.8, we have a 2-solution problem. So now that we know that we have a 2-solution problem, our first step is to find one of the angles. Well, we're going to use law of sines here. And anytime we have SSA, we're going to use law of sines. We can see that here if I pull out the law of cosines and compare it with our law of sines formula. Law of cosines says c squared equals a squared plus b squared. We don't have c, so that could be something we could find. We do have a and b, which is good, but guess what? We don't have the angle for c either. That's why law of cosines doesn't work here. So we're going to put that away, and we're just going to look at law of sines. Now, law of sines says that I can do any ratio of a side with its opposite angle and set them equal to each other. So let's go ahead and find angle A, because I already know the B's, right? And I already know A here. So I'm going to say 28 over sine A equals, well, this would be sine 45, or 27, I mean, over sine 45. Let's cross multiply here. We get 28 sine 45 equals 27 sine A. Divide by 27, you get 28 sine 45 over 27 equals sine A. Take the inverse of each side, we'll get A equals sine inverse. Right, inverse of this cancels, inverse of this we have to do because we did it to this side. So we get 28 sine 45 over 27. So what's the angle there? Let's plug in the calculator. 28 sine 45 divided by 27. Let's do that inverse. We see that we end up with 47 point, we'll round to 10th, 0.2 degrees. Now what's that mean? That means A, this angle here, is 47.2. But that's not the only option because this side length is smaller than this side. So 27 could actually fit here, but it could also be an obtuse triangle and actually be this direction. So it could have 47.2 as its angle, or it could have the exact opposite of 47.2, which would be 180 minus 47.2 as its angle. So let's write the two options at the top. Option 1. Your angle A equals 47.2. Option 2. Your angle A equals 180 minus 47.2, which is, let's do 180, 47.2, 132.8. Those are your two options. Now we're going to evaluate each of these options from there. If angle A is 47.2, I know angle C to be 180 minus 47.2 minus 45, which tells me angle C is 87.8. So we got two pieces of information in option 1. Option 2, angle C equals 180 minus 45 minus 132.8, which would make that be 2.2 degrees. Holy smokes, that's small. Which would make sense. Their side lengths are basically the same. They're pretty close. That's going to be a pretty small angle there for your angle C, which is this top corner angle, with its obtuse angle. Real small. So now we just need to find side C, and we're done. Well, we now have angle C for each of these. So we can do this twice. I always go back to the original, so I'm going to say 27 over sine 45 equals, I'm going to say that this is C over sine 87.8. Multiply that across, I get 27 sine 87.8 divided by sine 45 equals C. So C equals 27 sine 87.8 divided by sine 45, 38.2. Do the same thing over here, except for use the 2.2 for angle C. So we're going to say 27 over sine 45 equals C over sine 2.2. Cross multiply, we get 27 sine 2.2 divided by sine 45 equals C. Let's plug that in. Sine, or 27, sine 2.2 divided by sine 45. And we get a side length C, which should be small, of 1.5. So our two possible triangles, right, if we solve this thing, our two possible solutions, 47, 87.8 for the angles, and 38.2 for the side length C, or 132.8, 2.2 for the degrees, and 1.5 for C.